All right, guys, session 2 quickly. I gave you a question offline, so let's quickly answer that question on rates. And from what I see, it's a very straightforward question. It's a normal thing that I expect everyone to know. We are given a Maxwell-Boltzmann distribution, and every time you see this is talking about the distribution of particles based on temperature. Graphically represents a Maxwell-Boltzmann distribution curve for a reaction mixture at 300 degrees Celsius. All right, so I know this is 300. Area X represents the number of molecules in the mixture that have enough kinetic what? Energy. I hope it's okay for me to say that these are the only ones that will react. Why are they the ones that will react? For a reaction to occur, two things must take place. Particles must collide in the correct orientation, and they must have enough kinetic what? And what do we mean by enough kinetic energy? Huh? You guys are whispering. Please talk to me. Talk to me. You guys are whispering. I want you to talk. For a reaction to occur, two things must happen. What are they? A reaction. Reaction is about collision of particles, right? So what? And for reaction to occur, we must actually have what you call what? Effective collisions. If a collision is not effective, then there's no reaction. Now, here's my question. What are the things that make a collision effective? You gave me the first one. You said what? Okay, fair. We said they must collide in the correct what? Orientation. Correct orientation. Then what? Activation energy. They must have sufficient energy. I want you to use the correct language. And what do we mean by sufficient energy? Now we talk about what you're telling me. We talk about what? Kinetic energy greater than activation energy. Is that okay? EK must be greater than what? Now, what is activation energy? Minimum what? All right. Minimum energy required to do what? To start a reaction or for a reaction to take place or occur. Beautiful. So with that definition, we all okay with that. What are the factors that affect the... Okay, what is collision frequency? Let's quickly talk about that. What is collision frequency? Anybody? It is a... Go ahead. Number of... You're on the right track. Number of... Number of effective collisions per unit time. It's wrong. Because what if it's not seconds? Per unit time is more appropriate because you can measure it per hour. You can measure it per minute. Although standard-wise per second. All right. Whatever increases this collision frequency would increase the rate of reaction. How can I increase the rate at which particles collide? All right, beautiful. So, number one is higher. I want you to see it as people normally say factors that affect the rate of reaction. And they don't make you see what's really going on. It's not really factors that affect the rate of reaction. It is factors that cause the collision frequency to increase. It's better that way. When you see it that way, you remember quickly. Number one, you talk about what? Temperature. Increase in temperature. Increase in concentration. Increase in pressure at surface area, state of division, catalyst, and the nature of reactants. Let's make a list quickly. You must know how those 6, please, affect. Number one, temperature. Number 2, I'm listening to you. Concentration. Number 3, catalyst. Number 4, state of division. And what is the state of division? We're talking about the surface area. Number 5, pressure. But pressure only affects what? Gases. And number 6, nature of reactant. And the nature of reactant, I can actually explain that in 2 forms. Number 1, reactivity. And number 2, percentage purity. Nature of reactants. If a substance is very pure, what happens? More particles are then available. The collision frequency will increase and the rate of reaction will increase. Please be able to, it's 4 marks here, minimum of 3. Be able to tell how temperature, don't just say temperature, increase in temperature increases rate of reaction. No, that's babyish. How will increase in temperature affect the rate of reaction? Increase in temperature will increase the kinetic energy, right? Then what happens? All right, but I want us to use chemistry language. More effective collisions per unit time. That's 1 mark. Yes. And then what happens at the end? The rate of reaction will increase. Please, you see these last two statements. Number of effective collisions increase. Number of effective collisions per unit time increases. This one is very important. And then finally, the rate of reaction will what? Increase. These last 2 statements are very important when you are explaining according to collision theory. So increase in temperature will increase kinetic energy. So I'm just going to link all of this. Increase in temperature, kinetic energy will what? Increase. What happens? Number of effective collisions per unit time increase. Rate, I don't know if what I'm saying makes sense. Concentration, what happens? The number of moles of substance available. What will happen? It will increase. And if that happens, the number of effective collisions per unit time will increase. What about the catalyst? It lowers what? Activation what? Energy. It means more particles now have enough what? Kinetic energy. And when that happens, the number of effective collisions per unit time will increase, and then the rate of reaction will increase. State of division and surface area. If that increases, what happens? Number of particles available will also what? Increase. If that increases, what happens? The number of effective collisions will increase, the rate of reaction will. Can you see that? I keep going back to the last 2. Reactivity. Some reactants in group 1 are more reactive than group 2. That's grade 10. All right? As reactivity increases, the rate of reaction. I should stop talking about grade 10. Okay, all right. It's hurting you. It's too personal. Okay. All right, I'll try. See how you're laughing. Yeah, they said I should stop talking about grade 10. That, yeah, hurt. It's hurting. What's wrong? It's hurting people. So, huh? percentage purity, the more pure a substance is, what happens? More particles are available. Makes sense? If it's more pure, more particles are available. If that happens, the number of effective collisions will increase, the rate of reaction will increase. I think we can answer this question now. I'm eager to see if there's a stoichiometry calculation on this. We did one stoichio yesterday, right? If they ask you a stoichio question, you're going to do the exact same thing we did yesterday. All right? Can we move? Okay. The secretary is still writing there. We good? All right. Oh, did we answer all the questions though? No, we didn't even answer any. But I'm sure you did. 5.1. Minimum energy needed to start. Beautiful. Activation and you guys are so smart. Activation energy. The temperature. What's wrong? The temperature of the mixture is now increased to 500. Which graph represents that? It's C. C is 500. It cannot be B. B. That if you said B, that means you didn't read the question from the top. It's B. Give a reason for your answer. Yes. What do you think it is? It was A. Okay. Why did you say it was A? All right. Great. Beautiful. Let me explain it this way. I'm hoping that I'll be able to get to your understanding. This is your school gate. Right? This is the school gate. And this particular day, the police comes to your school and says, only people with 50 rand will be able to go out of school. You'll be at school forever. All right, but definitely I'm sure there will be some people who would go out. But, you have your 50 bucks, you go. Now, but if we compare the number of people who would go out as compared to the number of people who would be in school, where do we have more? People will be, all right. And look at the distribution. There are people who have zero. They don't come to school with money no matter what. Parents don't give them money. They give you food, they give you juice, they drop you at school. They don't expect you to buy nothing. They give you crisp, they give you everything you need. Chocolate is there, sweet biscuit. Good. You know where you are? You are far end away from the school. That's where you are. That's your position. There are people with 40 rand. Where will they be standing? Very close at the gate. They are the ones holding the bar of the school, the gate. All right. So 49, 45, they are all there. But you'll find that majority of the learners would have between 10 and 30 bucks. That's where the majority would be. So there's a lot of them here. And those who don't have at all, they've decided to sleep at school. So if we draw this, that's you. If we draw this graph, it's going to look like that. The distribution. All of a sudden, your school principal says, no, man, I want to give everybody 10 rand each. What happens? Good. The ones with 40 will go out. What happens? Wait, it means everybody's money is now increased by what? 10 rand. Higher amount of money. How many learners will remain at school? As compared to before, the number will decrease at a higher amount of money. So, if it decreases, is it okay to say this? And more would go out now. Does that make sense? That this one is at a higher amount of money, which is basically a higher what? Temperature. You still no, now you have 10 rand, don't worry. Except you are owing the school. And they start deducting. But I hope it makes sense. So C will always, the one lower will be the higher temperature. Okay. You see A, they are now collecting from people. Even those who are outside will be forced to come inside. If you didn't run away, you went out. Remember, you needed 50 rand to go out. Now they are collecting 10 rand from everyone. Those who are outside, what happens? You drag them back to school. What happens to the number of people in school? It increases at a lower amount. All right. So, are we okay with graph C, everybody? Lovely. Give a reason for your answer. I think you can just explain what we did right. Please don't use, for example, money. Don't say that. When temperature increases, more particles have enough kinetic energy than activation what? Energy. That's what we're saying. When energy increases, more particles have enough kinetic energy. Guys, and I think I've answered 5.2.3. I told you it's 4 marks. Can you see the 4 marks there? Use collision theory to explain how this increase in temperature will influence the rate of reaction. Increase in temperature will increase what? The kinetic energy of particles. Is that okay? Particles will collide what? Faster. Number of effective collisions per unit time will increase and rate of reaction will increase. You are done there. Please write it in bullet forms. Don't write stories. Now you should get the 4. Please write it in bullet forms. Let your answer be in bullet form. Number 1, increase in temperature will what? If we increase temperature, don't write stories. What's going to happen? Kinetic energy of what? Particles will increase. Please, let's state the fact that more particles, that it increases doesn't mean there's a reaction. That we gave you 10 rand doesn't mean you're still going home. What makes you go home? That you must be at least have the threshold. Okay, some of you are going to stay in school forever. You'll become, more particles have what? Enough kinetic energy above activation what? Energy. You know the last 2 points. Number of, and what happens? Rate of reaction will increase. Are we okay? It's straight 4 marks. Don't waste time. Can I move on? I want you to do something for me though. When you're done writing, draw this graph in your book. I need you to draw graph B. Only graph B. More particles have enough kinetic energy. Yeah. But don't write symbols. Write it in full. Don't write greater than. Write it. If you are writing greater than, spell it out. Greater than. Don't write the symbol. All right, everyone, those of you at home as well, please quickly draw this graph. I want you to draw just graph B. Let's check something. Draw graph B and draw the activation energy there. No, that Y is activation energy, Nana. Oh. This is E Amos. Right? The activation energy setting. Oh, you girls are so meticulous. You have to draw with a ruler. All right, are we done? Write EA there. Don't write Y. Write EA. EA. Activation energy. All right. That's your Maxwell-Boltzmann distribution curve, right? Can you then draw, if we add a catalyst to this, What will my Maxwell-Boltzmann distribution curve look like? This is the question. You have the question right now, right? Good. Now I have added what? A catalyst. What will the graph look like? Draw. What will the graph look like? What will the graph look like? Those of you at home, you're going to mark yourself. What will the graph look like? Nope. So that nope. No. Now it's out completely. Nope. It's very simple, guys. Let's ask ourselves, what will the catalyst do? It will what? It will lower the activation energy. We are done. All you need to do is to bring it back. You are done.
That's what I did.
I
didn't draw the line, but I just moved the entire graph very. So that's what I just drew it through.
That's all you have to do. I don't know if it makes sense. It decreases activation what? Energy. So it brings it back. That's all. I saw she was already moving there. She wanted to draw another graph. Are we okay, guys? Did it make sense? It lowers activation what? Energy, which means it reduces. So you just need to draw it at the back. That's all.
So how do you draw it back?
Look at the green one. That's my EA of a catalyst. Yeah, just draw the line. What you guys are drawing, you guys are drawing potential energy graph. That's what you. This is Maxwell-Boltzmann distribution curve. All right, please mark yourself there. Mark yourself wrong. All right. Do you know I've answered all of this question now? A catalyst is added. What is a catalyst? A substance that what? All right, please. That second part is important. A catalyst is ideally, we should define a catalyst as a substance that what? Okay, according to your level, we'll just leave it at your level though. Because what you are defining for me is a positive catalyst. Check your definition pages. A positive catalyst is a substance that increases the rate of reaction without itself taking part in the reaction or undergoing what? A permanent change. That's acceptable, but when you get to varsity, it's wrong. A substance that increases the rate of reaction without undergoing a chemical change. An examiner will give you something like this. Check this. Guys, I want to be an examiner. No, I just ask for simple things. Simple things. Which one is the catalyst here? C is the catalyst. Simple things. You define it that it must not undergo a change. So if it goes in at C, it must come out as what? C. So C is the catalyst. I think I'll be wicked, shame. But I'll be asking you for a basic application of, but is it making sense? It speeds up the rate of reaction without undergoing what? So if it goes in at C, it must come out at what? At C. How will the above mentioned action affect the size of area X? If you were listening, you should be able to answer that. It will what? It will increase. And what's the reason? It lowers the activation what? Energy. Make sense? It lowers the activation what? Energy. So that more particles will then what? Have enough what? Kinetic energy above. Let me ask you one more. Why is there no stoichiometry here? Nonsense. Need to look for one with a stoichiometry. We need to look for one. Guys, look at this quickly. If I give you this. Check this. Maxwell-Boltzmann distribution for concentration. C1. Concentration. Please draw this graph in your book again. Draw this again quickly. Let's move on to chemical equilibrium. I hope there's time. I want to do one more question on this one that has a stoichiometry. Let me look for it while draw this graph. I need to look for a stoichiometry question quickly. All right, when you're done drawing, you know what I want you to draw? If we increase concentration, draw the graph. We've done temperature, right? We've done catalyst. Now, this is concentration 1. Increase the concentration, draw the new Maxwell-Boltzmann distribution. If we increase the concentration, what will my graph look like? Tell me you are done. All right. Let's be done. This is what's going to look like. If I increase concentration, and I'm done. That's just it. That is it. All right. I found a question. Quickly. Can I throw this question? All right. We are done with this one. We are done with that one. We've got to move very fast. Please, you don't have a choice. Tell your parents. You won't. Don't blame me, guys, for that. You know who to blame. You blame me. I'm sorry. I've apologized. Somebody else should also apologize, though. You are forgiven. Yes.
Guys, I love how all of them are apologizing. Guys, can I please talk? I love how you are all apologizing.
Where's Mr. God?
If I typed out the message, then it was 4 to 1. 1 to 4, but it's fine.
Guys, come was watching. Hello, come.
And then edited you was just a lot.
All right, guys. We're going to do this question in two folds. We're going to do it. Please quickly handle this, 5 marks, and then the rest would come. Please don't let's waste time. I'll give you 5 minutes for this. Quickly, 5 minutes, so that you can read. Yes, it's 113 there. There's no. Once you read, you are able to answer this. Quickly, let's answer. Change in concentration of product or reactants per unit time. That's 1.1 there. Rate of reaction. Change in concentration of reactants or products per. You must get that mark.
So when you say it's the time taken
Uh-uh.
for the reactants to form
It's
products,
changing concentration.
It's wrong.
So,
Of reactants or products per unit time.
so if I say it's the rate of products formed per unit and there is
Wrong. You cannot use the word rate and unit time. So it's the because we're saying our formula should be what? Where is it again? Rate of reaction is change in concentration of products over what? Or the change in concentration of reactants. Are we okay? It's the change in concentration of reactants or products per unit time. We're done. Let us use the reaction between impure powdered calcium carbonate and excess. Wait, we've spoken about this word today, impure. Under what? It was under one of those factors. That impure, the nature of reactants. Okay. The balanced equation is given as that. For experiment, I'm sure you all read the story. Don't have to read again. The results of experiment 1 and 3 are compared in this investigation. Write down the independent variable. Which one is the independent variable? Experiment 1 and 3. What's the difference? Temperature. So that becomes my independent what? Variable. What is the dependent variable? The rate of reaction. Because we are saying temperature is or rate of reaction is dependent on temperature. Use collision theory to explain why the reaction rate in experiment 4 will be higher than experiment 3. What do you notice about what's the difference between 4 and 3? Now, okay, so how would you explain that?
the mass increases the numbers of particles available, even though it's impure, it still increases the number of particles available, which increases the number of effect of collisions, which increases.
All right.
Yeah.
Okay, yeah, kind of, but there's something yet you said the mass increases. That the mass increases doesn't mean that the number of particles. What if I increase the mass of the impurities? I don't know if it makes sense though. If I increase the mass of impurities, still doesn't help me. You want to help me there? Okay, you see, there's one thing I just wanted to emphasize. When it comes to chemistry, be very direct. Not really. We're not comparing surface area. This is what I just need to emphasize. You guys are close, but I just need to emphasize that if we increase the mass, there are more pure substances. I want you to be very clear. Because you can't just say we increase the mass. No. The number of pure substances will what? Increase. And that is your percent. The answer is here. You have the answer in your book. There's no need to write. Guys, check here. The answer is there. Percentage purity. Number of particles. Now we say number of pure particles. What? I wanted to mention that pure. I hope it makes sense. Because we can add impurities to make it up to 25. Make sense? What are we increasing? Impurities. But the number of pure substances are still what? The same. So the number of pure substances will what? Increase. And that will just answer It decreases. All right. And once you answer that, what do you say? Number of effective collisions per unit time increase, and the rate of reaction will increase. So the examiner here, I love this examiner. A lot of you would think they are testing surface area, but no, they are testing nature of reactants. All right. Nature of reactants was being tested there. Okay, the question continues. Guys at home, I hope you're okay. I hope we are okay. You know what to do, right? Yeah, Tundani used to do that. Give me a thumbs up. Today she's here, I can see her face now. All right, there we go. Please, the learners obtained, please, I want you to watch this because we're going to be going, let me try to do something. Because I don't want to go forth and back. We have to compare. I hope this helps. All right, check. Please check. The learners obtain graphs A, B, C, D below for their results. I want you to write which one is A, which one is B, which one is C, which one is D, according to the following experiment. Experiment 1, 2, 3, 4. Quickly, let's get that done before we even answer the question. It's 6 marks there. But write which one is A, B. You have 2 minutes. Give me which one is A, B, C, D. Let's see how many minutes we have on this. Why would you say minus 6 marks, man? Come on. Thank you, Tina. 3 minutes. Can I just send a new link quickly here? Thank you, Tina. You are such a star. Guys, start migrating, start moving. Start moving. Move now, quickly. Let me charge for you here. Minute, move. There's a new link for you. Paul, please move. Soyama, please move. You can eat, guys. You can eat while we're having class. All right, guys, welcome back. Let's have answers to this question quickly. Okay, look at experiment 1, 2, 3, 4. Which one is very different? 4. 4 is very different in terms of the mass that we are using. If I use a bigger mass of reactant, I'm expecting a bigger mass of product. So automatically, I'm already done with my number 4. My number 4 is A. And the reason is very simple. I have more product produced because I have more reactants. It's 25 grams as compared to the rest. More reactants? Yes. Okay, hold on. I wanted to check this. All of these are 15. No matter what you do, we will have the same product. What will be different is how fast we produce them. That's why these 3 graphs, can you see volume produced? I don't know if it's making sense. You are cooking 3 cups of rice. One, you use a candle. Second one, you use a stove. The third one, you use what? A hot plate. Or you use, if you are from the village, like me, you use the wood. Do you think the rice on the candle will be more in quantity when we are done than the rice on the wood? Same level. So if it's... Because I use the same mass. So I'm expecting to produce what? The same product. What will be different is the time. The time it takes. I said, here we have what? 15, 15, 15 as my raw material. So at the end of the day, I will be producing exactly the same thing. What will be different? And that's why we call it the rate. It is the time frame it takes to have. That's why this is volume of carbon dioxide produced. They are all the same. So B, C, D is somewhere here. This one is higher because we have more reactants. Hence, I have more what? Products. Are we good? All right. Now let's look at 1, 2, 3. Which one is the slowest? 2 is the slowest. Why? Lower concentration. So which graph would represent 2? D. Does that make sense? It takes a longer time. It's the slowest. Because of low concentration. I have between 1 and 3 now. Which one? Talk to me. Which one? Those of you from home, why are you not talking to me today? I want answers from you. 1 and 3. Come on. Venusia, Refiwe, Gugu, Gracia, Emmanuel, Sonyama, Tina, Sia, Minentle. Come on, talk to me. What's the story? Oh, did you send a new link to, is it Cam? Tina says B is 1. Do we agree? Okay, look at 1 and 3. Which one will be faster? 3 will be faster. Why is 3 faster? Because of the temperature. So, which one? B. B is 3. Agreed? Because that's the time. And what about C? Please let me know if it makes sense. C. Vele. Did you get the 4 correct? I said I asked for the 4. All right. You will be able to do it, don't worry. Fully explain your answer by comparing experiment 1 with 2, 1 with 3, and 1 with 4. 1 and 2, what are you going to tell me? 1 is faster than 2 because of higher concentration. Please mention higher concentration. 1 and 3. 3 is faster than 1 because 3 has a higher what? Temperature. 1 and 4. 4 is higher. 2 things. Higher concentration and higher number of particles available. Be careful of the word mass. When we listed all the factors, we never listed mass. Did you notice? When we listed all the factors, we never... States of division and mass are completely different. I could have 1 gram of a powder and 1 gram of a solid. Makes sense? 1 gram of mincemeat and 1 gram of chunk. I know you love food. The excitement on your face when I said meat. But it's still 1 gram. All right. D. No, not the lowest volume. They all have the same volume. No. This graph, okay guys, this graph is only telling you that the volume produced per time. At the end of the day, we are going to get here. It's like going to the mall. Somebody's walking, somebody's in a bike, and somebody's driving. Where are we going to end up? At the mall. What's going to be different? The time. Make sense? So we are all getting there. Only that when you get there, they might be closed. Because you are walking. All right. Guys, let's look at this stoichiometry. We need to move to the next concept. If you were listening in class yesterday, let me see. I've got some notes online. Let's see who's talking there. See, yes, so sir, mass doesn't affect. No. Mass does not affect. What you need to state is the number of particles. Minently, are you okay with 1 and 3? 1 and 3. 3 has a higher temperature. All right. Guys, do you want to try that stoichiometry for me? Let's see what you get out of 5 marks. I'll give you 5 minutes. Why are you fighting, Nana? Here's the reaction. You need the reaction. Calcium carbonate plus 2 moles of hydrochloric acid would give us calcium chloride, carbon dioxide plus water. 5 minutes. Thank you. Let's see what you got. Calcium is 40, carbon is 12, oxygen is 16, hydrogen is 1 in case you need it, chlorine is 35,5. Yep. Let's see. Oh, did I put time? Yes. And I didn't start. Let's make it 6. Please, guys, I don't want you to get a 0 on this. Please get me marks. You see, I increased the time. 6 minutes, 30 seconds. I don't want a 0. I'll add 2 minutes. Okay, guys, let's walk through together quickly. Again, this is basic stoichiometry. Very, very basic stoichiometry. Please, I want you to listen and follow the question. This is how you do your stoichiometry questions. I'll start by writing out the equation. I'm going to do this in about 5 minutes so we can move on to KC. Calcium carbonate plus 2 moles of hydrochloric acid to give me what? Calcium chloride. All right. Very first information that I want you to know is this. Only pure substances react. Please take note of that. Only pure substances what? React. What are we looking for? We're looking for the mass of the impurities. Are you with me there? In experiment 4, what do we know? We know the total mass of this. Okay, I want you to follow me so that you'll be able to see the reason. It's not just about writing down answers here. Total is 24. But this total is what? Impure plus what? Pure. Since only pure substances react, this reaction, my stoichiometry would only deal with this guy. Out of 25, do I know the mass of the pure? No. How will I get the mass of the pure? Number of moles is mass over molar mass. Please don't bring in 25 here. Never ever calculate number of moles of impure. Please don't. Because there are impurities there. Alright? Huh? You get it right so far? Good. So what do I need? This I can get. What do I need? Number of moles. But I told you, they will not give you that number of moles. 3 steps. Find the number of moles that reacted or that is produced. They gave us information somewhere. Let's go back and read. What did they give us? The gas formed is 4,5D. Oh, which gas? Carbon dioxide. and they gave us the molar volume. What is your molar volume? 25, comma what? VM. So now, can I work out the number of moles produced here? That's my step 1 that I gave you yesterday. So, step 1, number of moles of CO2 produced is volume over molar volume. 4 over 5, 25,7. What's your answer? I'm done. Step 2, I can now connect mole what? Ratio. 1:1. Do I know this? Yes. Do I know this? No. Can I cross multiply? Number of moles of calcium carbonate, therefore, is, which is what I'm looking for here. Make sense? Can I throw that back in now? The number of moles of calcium carbonate, therefore, is mass over molar mass. What is this? 0,1750 mass over 100. What is the mass of the pure? Cross multiply. Mass of impurities, what will it be? 25 minus. Can I tell you something about chemistry? Let me tell you something I love about chemistry and physics. Let's say I got 20 there. I did whatever calculation, I got 20. I got 20, but I came here and subtracted. I'll get 1 mark for subtracting. The skill. No, I could have gotten formulas, and I'm just saying that you'll get that mark for subtraction. What's your answer? 7,5. What if they ask you to find 5? You see? What if they ask you to find percentage purity? No. What's the formula? Mass of pure substance over total sample of impure, total mass of impure, multiplied by what? What is the mass of the pure? 17,5. What is the total sample? 25. Times what? 100. That's percentage purity. We're done. Mass of pure substance over total sample of impure. Yes, who's there? Talk to me, Emmanuel. Hi, Emmanuel. Talk to Ma.
So I just want to ask, how did you know that CO2 was the gas that was produced?
Emmanuel, you must know the gas in the reaction. Check.
Oh, okay.
You must actually know that CO2 is carbon dioxide, and that's the gas.
Oh. So it's the confusing thing was when we're copying down the chemical formula that you gave, you couldn't write the base of matter. So I was more confused. So which one is the gas and
as a grade 12 learner, you should know that. That carbon dioxide, every time, and it's acid and base. Every time you have an acid reacting with a carbonate, if you check your notes on acid and base that I gave you, carbon dioxide will be produced, and that's the gas.
Okay, thank you.
Awesome, great. Do you want to give me an answer here? 7-0. All right. Good. Great question. I love it. If you are not clear about anything, please ask. Is that okay? At least now we know. We're good. Can I move to chemical equilibrium? No. You called me? Oh. You said I came here. I thought you called me. So why were you stuck? So the idea, make a list of the things you have underneath each of them. Can I move on? Those of you at home, are you okay with the stoichiometry? Please, very important. All right, let's see quickly from that same paper. All right, this paper is the Limpopo paper that was written this year. Okay, so yesterday we already dealt with all of this. We dealt with all of this yesterday. This we dealt with. Remember, we said that's 29 marks. Let's play here. Let's play. Let's do the big boys. Let's play around the big boys. You know, that came out so wrong. All right, guys, listen to me here. Acid and base. Before we even jump into calculations, there's a simple theory. Define, identify. Please, I know learners always say acid and base. Wow. Yes, Nana. Oh, you are no. Write down. We have 5 marks. Please get me these 5 marks. I don't want stories. This is basic theory, introduction of acid and base. Please, let's answer this theory. Yeah, I remember I said chemically, but as I was scrolling up, I stopped. Let's play now with it. Let's have fun here. You have 4 minutes. Please write down as you would be writing in your exam. We want to keep marking every activity. Write it the way you would be writing down in your exam. Can we mark? All right. Let's mark. Those of you at home, please also put ticks as well. Define an acid in terms of Lowry Bronsted. An acid is a proton donor. Give a reason why sulfuric acid is a diprotic acid. Please, you said a donor. So what's going to happen? It donates 2 what? Protons. Don't say it shares. You said it's a proton donor. So keep that word. The vision. All right. The hydrogen carbonate ion can act as both acid and a base. What is that? Ampholyte. They said the hydrogen carbonate ion acts as a base in the above reaction. Write down the formula. Can you quickly identify our pair here? If you look at this, please, guys, this is very important. Sometimes this is 4 marks. HCO3 looks like this one. But what's the difference? This one is 1 hydrogen less. This is 2, right? It means this guy has what? Received. Does that make sense? A proton has been transferred from water to this guy. So water is acting as my acid, and this is acting as my what? When a base accepts a proton, what does it become? A conjugate what? Acid. When an acid donates a proton, what does it become? A conjugate base. So what's my answer for this? H2CO3. Guys, please, I need you, before we start struggling with the 8 marks, 10 marks of acid and base, these marks are in, you cannot lose these marks and still go and lose the 10 marks. I don't know, it doesn't make sense to me. All right, 7.3 now. Yeah, we're going for the big guy. All right, 6 marks. There we go. I need you to make an attempt. Remember, the idea is not to get a 0. Okay, idea is not to get a 0. 6 marks, I'll give you 8 minutes. I'll write all the formulas that we may need. What do we need? Concentration equals to number of moles over volume. Hydrogen is 1, sulfur is 32, oxygen is 16, sodium is 23, carbon is 12. What else do we need? I think that is all. Yeah, we don't need anything pH. Are we given any pH here? No. Great. Oh, we need this formula. This formula is also given. All right, this is everything you should need. Please don't get 0. All right, guys. Those of you at home, you want to share answers with me quickly? Google. This is your favorite. Give me an answer. Google, Minentle, Sia, Tina, Suyama. She's laughing. I'm serious. Fifi, give me an answer. I know you love acid and base. Refili, why are you laughing? People are laughing. No, guys. I'm serious here. You guys are laughing. All right, let's see. Let's check. What would I do if I were you? I'll read. A chemist spills sulfuric acid of concentration 6 moles per dm cube from a flask on a laboratory bench. She Please, I want you to listen to that word. She what? Neutralize it. Please, my beautiful learners, when I see that, first thing, when I see the word neutralize, and I check that my reactant and product are in the aqueous phase, I am going to bring in this formula. Please take note. When do I bring in that formula? When I see the word what? Neutralize, and I check my reactant and product, I see they are in what? Aqueous phase. Okay. Don't just bring that pin in. Make sure it's an aqueous. I see there's a problem here. One of them is not an aqueous. So I don't know yet. Okay. All right. The reaction that takes place is assume that ionizes completely. So we have this reaction. The fission, due to the formation of what? Carbon dioxide, stop after the chemist has added what? 27 grams. So the mass here is what? 27 grams of sodium hydrogen carbonate to the spilled acid. My beautiful learners, please watch the beauty of this. Calculate the volume of sulfuric what? Acid. How would you get volume? Are you aware that we're going to use N equals to what? Or C equals to N over V? Okay. Please, I want you to start from there. Examiner says get the volume. So for H2SO4, I know that C equals to N over V. Do we know the concentration? What do you mean no? First line, 6. What is my problem? Number of moles. What is the instruction? They will not give you the number of moles that you need. What is step 1? Calculate the number of moles of that is used or react or produced of the other what? Substance. Which other substance do we have information about? Sodium hydrogen what? Carbonate. Do we have the mass? So we know that the entire mass reacted because they said the fission stop when we have added what? 27. So we used all the 27 grams. Make sense? Can we calculate the number of moles there? Beautiful. Number of moles of sodium hydrogen carbonate is mass over molar mass. Mass over molar mass. All right? Mass over mass over molar mass. All right, quickly. Are we okay with the process so far? Number of moles is mass over what? Molar mass. Do we know the number of moles? No. But do we know the mass? Okay, quickly, let's get this. Mass is what? Is it 27? Yes. What is the molar mass? 80? Are you sure? Confirmed? Do we agree that the molar mass is 84? Yes. 84. All right. I hope everybody knows how to get that. What is your mass? Number of moles? Quickly. 0, comma? All right. Let's leave it unto 4 decimal places so we don't round off quickly. Moles. Of which compound? NaHCO3. We are done there. What's the next step? Mole ratio. So if you get something like this in your paper, we need to do a few more different types, right? But if you get something like this, I want you to be just, sweep all the marks. What do we have? H2SO4 and what? NaHCO3. What's the mole ratio? Which one is 2? All right. No, I wasn't sure which one is 2. Okay. What do we have? 0, comma what? 3, 2, 1, 4. N. Can we cross multiply? 2n, right? What would this be? 0, comma 3, 2, 1, 4 divided by 2. Do we agree? What's the answer going to be? 1607. Moles of which compound? H2SO4. Can I go to step 3? What do I know? Concentration is number of moles over volume. Do I know my concentration? What's the concentration? 6. N. Do I know N? 0,1607. And I'm looking for what? Volume. What will this be? 0,1607 divided by what? 6. 0,03. Cubic what? 6 marks. Done. No, it's correct. Guys, even if it was aqueous, I could still use the same steps. I don't even have to use Na over Nb. If it's aqueous, I know that I need to calculate the number of most of the other substance. I could use Cv. So you don't even have to use that Na over Nb. The 3 steps will always work. Let me know if we are okay, guys. Those of us at home. Did it make sense? We're good. Beautiful. If you have been following me, this is nothing compared to the ones we've done, right? We've done quite a lot of this. Okay, can I move on? We're good. We got it. Sweet. It basically follows the same 3 steps that we spoke about earlier on. That is stoichiometry. Okay. Guys, we are moving together. I thought we were done. There's still 8 marks waiting. During the titration, 25 cm cube of the 0,1 moles per dm cube sulfuric acid is added to an Erlenmeyer flask and titrated with 0,1 mole per dm cube sodium hydroxide. All right, this is what I'm looking for. I love this one. I was hoping that I would do something like this, and it's beautiful. It combines the 2. The chemist used bromothermal blue as indicator. What is the purpose of the indicator? To show the end point. What is end point? That's what we need to ask ourselves. End point is the point of neutralization. All right, end point. It's the point where indicator changes. Point where indicator what? Changes. And that shows neutralization. So what is the purpose of the indicator? To tell us when neutralization is complete. To tell us when neutralization is complete. Please, I quickly want to define 2 points for you: endpoint and equivalent point. They might ask you this. What does the word equi mean? That's what should come to your mind. Equi means what? Equal. So what is equivalent point? It's a point where the number of moles of the acid, is equal to the number of moles of the base. So the indicator will tell you that we have reached complete what? Neutralization. I'm going to ask you to try the next question. 8 marks. What will you get? Please don't tell me 0. Yeah, 10 minutes. Agreed. I'll give you 10. Yes, ma'am. Okay. But let's say you get into the exam and you see this. What would you do? I'll give you the pH formula. This is the formula for pH. pH equals to negative log hydronium ion concentration. And then you have Kw is hydronium ion concentration. Let's say you get into the exam the way you are without coming to this class. I don't want you to get a 0. There must be something. Write a formula, do a substitution, do something. I don't know if what I'm saying makes sense. No. Very different. All right, thank you, Tina. We have 5 minutes. I'm going to send a new link. But this one, 10 minutes. Please, you have 10 minutes. I want you to try. What would you do? And I'll show you. I was actually hoping that we get something like this. And I'm glad that it came through. I am so glad that it came through. I am very, very glad. I am so happy. No sorrow, no sigh. We may start moving. All right, those of you at home, please start moving now, quickly. 30 seconds. Move now. Move to the next link. Quickly. The link is open so that I can share my screen. Tina, please move. Yeni, please move. Refill, move to the new link, please. 1 second. There was no equation. No, you should write. The examiner did not give an equation. They expect you to be able to tell what's going on between sodium hydroxide and sulfuric acid. It's basic. So we must be able to write some of those equations. They didn't give us. When an acid reacts with a base, what are we expecting? Salt and water. So that's, they want you to be able to write that. And then balance, remember? Must be balanced. Okay. Thumbs up, thumbs down so far. What are you saying? Quickly. Thumbs up, thumbs down. Give me a reaction. Manuel. Google, what are you thinking? All right, my beautiful learners. Let me take you through these 8 marks. And please, I'm going to be very slow. I want you to listen to the process. Is that okay? I'll take it very slowly just for you to be able to understand. During the titration, 25 cm cube of 0.1 moles per dm cube sulfuric acid solution is added to Erlenmeyer flask and titrated with sodium hydroxide. Now, the first thing here, the examiner is expecting you to be able to write that equation. How did I get that equation? I need to show you. All right. So, what do we have? We have sulfuric what? Acid, which is H2SO4 plus what? Sodium. Please, whenever you have this reaction, you know you are going to have salt and water. The first thing you need to do is to ionize your substance. What will this give me? H plus, SO4, 2 minus. That 2 by the hydrogen goes up there. What do I have here? Na plus and what? OH minus. What do we then do? Grade 10. Ion exchange. The hydrogen, the plus here will take on the negative here. Can you see my H2O already forming? H plus OH would give me what? H2O plus. Now, in grade 10, we taught you this. Please take note, we always write the positive one first. The only place where the negative comes first is when you have your ethanoic acid. But others, positive would come before the negative. Now watch this. There's a 2 here. What do we do? Do you remember this issue of cross multiplication there? We did it in grade 10. Okay, sorry. I said I'll stop talking about grade 10. But what this means, let me tell you what's going on here. Please watch this. We are saying sodium says I can give out 1 electron. Sulfate ion says, Mara, sodium, you're not fair. I need what? 2. The negative means I am short of 2. Sodium says I have an extra of 1. How then do we get into a relationship if you cannot give me what I want? Sodium then says, don't worry, I've got a twin. A side chick. So what's going to happen? Sodium would bring another pal. I don't know if it makes sense. So that this guy would give 1 electron, this guy would give 1. Oh, we now solve your problem. So how many sodium ions am I using? 2. Na2SO4. Did it make sense? It's all about what I can give and what you can take. Can we balance? All right. Sodium, how many sodium on the right hand side? 2. So we need to put a 2 here. But that affects my hydrogen immediately. Hydrogen on the left hand side becomes what? 4. Because there's 2 on H2SO4, there's 2 on Na. I need a 2 there. And I think it's balanced. It is. You can check. It is balanced. So that's the process. Ionize, ion exchange. If there is a carbonate, first, can I do one with the carbonate? Quickly. Look at this. If I have NaHCO3 plus, let's say, H2SO4. Please watch this. What do I do here? Break this down. It's Na plus. It is H plus. Is that fine? I know there'll be a carbonate. So what do? I write a I know there's carbon dioxide. What am I left with? 1 more oxygen. Group 6. 2 minus. What do I have? H plus, SO4, 2 minus. What do you notice here? Check. Look at the explanation I gave you. How many hydrogens here? 2. How many oxygen atoms? 1. So what do we have? Already I have my H2O. Then I have my carbon dioxide. What's happening? I'm left with this and that. You remember that explanation? Sodium can give 1 sulfate, ion can accept what? 2. So what do I need? 2 sodium. All right, another twin, right? Na2. We then balance. Put a 2 there. Hydrogen is now 4. Are we okay, guys? It's about splitting and bringing back. An acid with a base would give you salt and water. An acid with a... You must know those... It's... Okay, don't let me say it. It's pretend, but... So, Nani, if you can take a picture of the list that I gave. I think I did 4 reactions. And just share with everyone. Probably when you get home or something. It's just a favor. All right, guys, are we let's move on. Are we okay with this? So the examiner expects us to be able to write that. So, what's our equation again? H2SO4 plus 2 moles of what? Please, I want you to follow this very closely. I'm going to finish this 8 marks. I don't even think I'll move to the next page of my slide for these 8 marks. So I'd love you to please listen carefully. Can we go back and read the question to see what's really going on again? Can I go back? All right. What did the examiner say? 25 cm cube of what? The sulfuric acid. This is what I like to do. Write all your information under each of the compounds. What do I know about the sulfuric acid? What is my volume? 25 what? Cubic what? Centimeter. What is the concentration? All right. Are we okay so far? It's added to an aluminum flask and titrated what? With 0,1 of what? So what do I know? I know the concentration here as what? Are you following my system? Okay, just interpreting. Take time. Calculate the pH of the what? Solution in the flask after the addition of what? 30 cubic centimeters. So we have added what? And the examiner says that what? The end point is not yet reached. This is incomplete what? Titration. There's incomplete, there's over titration as well. Okay, but my beautiful learners, let's start. What are we looking for? pH. Always start from what you are told to write. I'm looking for pH of the final what? Solution. What is the formula for pH? pH will be equal to what? Negative log. Are you with me? Hydronium ion what? Concept. Please, I don't want you to lose me. I want to take it slowly. Are you okay with that one? It's a copy and paste system. What does this block bracket mean? Concentration. Wait, do we have a formula for concentration, by the way? C equals to what? Oh, so it means they are actually saying, check, if I write it this way, will it make sense? We good? Are you with me? Lovely. The problem is, we are dealing with the final what? Solution. Please follow. You're going to get it. This one is supposed to be the final what? Solution. Okay. Do we have the volume of the final solution? Please listen. Volume of the final solution is what? Is 25 plus 30. Talk to me. You are pouring two things together. Okay, wait.
Was he getting what? You said it was added.
Yeah, it was added. It's as simple as that. Just follow the instruction. It was added. Guys, it was just added. Don't even do so many stories. Check here. I have, which one was added? 30 cm cube was added. So, look, I have sulfuric acid here in this beaker. Is that fine? And I have what? Sodium hydrogen carbonate here. Is that okay? Wait. Then I take this and do what? Pour it inside. If I pour it inside, what's happening to the volume? It's increasing. Is that making sense? It's poured. You're surprised that it's poured. If I move it here, I'll have to mop. If I keep pouring, I need to get a mop here because it's going to pour. Like, I need to mop. But guys, is it making sense? Are you okay with my addition now? So, remember, please focus on what the examiner wants. The examiner says the final what? Solution. So what? Because when I say concentration, I'm talking about final what? Solution. There are two things to deal with here. Number of moles and volume. Are you okay with the volume of the final solution now? Please talk to me. Volume of the final solution is what? 55. Here is the main problem. If we can get over this problem, we are done with this question. What is N in the final solution? If we can get over this problem, we are done. And I would like you to listen to me. If I take an acid and a base, naturally there will be neutralization. My dear learners, I have a party in my house after class. Unfortunately, you guys need to go home at 6. Yes, class ends at 6 and I have a party at 6:30. No, you're going home. 1 second. You want to wait for the party? No. You're leaving at 6. No. I'm telling you that there's a party. Real, for real. You know. Okay, guys, so my party starts exactly when you leave. Please tell your parents to arrive early. Yeah, I'm having a party.
So you confuse us.
Just follow me. All right, guys, I'm going to continue, right? Okay, so okay, you need to focus now. I'm having a party at 6:15. Now, I have a friend who's coming with, my friends are coming in. All right? Guys, just follow me. Just follow. You'd know whether there's a party or not now. So, my friends are coming in. There are 7 boys coming in. All right, 7 guys. And we have 9 girls coming in. All right. We have 7 guys, and we have what? 9 girls. Now, look, it's natural as a young person in a party, you're looking for your type. Look, whether you say no or yes, I don't care. But it's natural. You get into a party. It's a party. Everybody's looking, that's my type. That one, I must get a number. I want to say hello to that one. And it's surprising, even the girls talk more than the boys. Some of you girls, the boy says hello, say my number is 012. He didn't even ask for your number. Say hi, 078. Yeah, we know you. Okay, but hold on. I want you to get this whole thing. Get this whole thing. How many boys do I have? 7. How many girls do I have? The girls are excess now. Right? Which means naturally boys and girls would neutralize based on number of moles. Acid and base will neutralize. When they are done neutralizing, we are going to check which one is excess. The one that is excess is the one that is active. Please, I need you to listen to me there. If you can get that, we are done with this question. The one, guys, when we say something is neutralized, it no longer has power. So I have acid, I have base. When I add the base, what happens to some of the acid? They get what? Neutralized. Based on mole ratio, based on content, I need to now find out which one. Do I have more acid than base in terms of number of moles? Basically, I'm saying which one is the limiting reagent. The final solution, please, I'm going to write this note for you. Final solution, concentration of final solution, and if you can see this, will be good, will be number of moles of excess over total volume. Because the number of moles is what determines, the excess one, it's what determines whether my final solution is an acid or a base. Okay, guys, I'd love you to please get that. Whatever is excess tells me if my final solution is what? An acid or a base. In my party, it's more of a girls' party now than a boys' party. Why? Girls are excess. If I have more boys, it's more of a boys' party. We can even watch soccer. You can imagine you are 3 boys and there are 8 girls. Oh, this class. And you want to watch soccer. The girls will overpower you. No, there's no soccer. They hide the remote. One girl will be a boy. But I don't know if my explanation makes sense. But check, we have 15 boys and we have 6 girls. It's soccer time. Especially on a Saturday. The girls can go to the kitchen. Or sit in the balcony. But it's soccer day. All right. No, girls would go and make us something to eat, but the boys will blaring the speakers, be watching Man City, whoop everybody. You know. Okay. Oh, Angela is not in. Angela is not in. I should have been saying Man City will be beating Arsenal. She's an Arsenal fan. But I don't know if what I'm saying makes sense. Please take note of this formula. The concentration of the final solution is the number of moles of the excess what? Substance over the total what? Volume. Number of moles of excess what? We now need to check which one is excess. Is it the acid or the base? Yes. Good. I will compare the mole ratio. Now let me teach you, how do I get limiting reagent? Because I need to find out which one is excess. Calculating, you need to do mole ratio. Is that okay? Can I walk through the calculation first before we start writing? All right. Calculating limiting reagent now. Limiting. Please watch this. Limiting what? Reagent. I have my acid and I have my base. Which one is the acid again? H2. I'm going to need your calculators, please, very quickly. And what? Sodium what? Hydroxide. Okay, I want you to follow me quickly here. Do I know the concentration here? 0,1. Do I know the volume of the acid? Never. 0,025 divided by 1,000. Okay, all right. Okay. What is the concentration here? 0,1. What is the volume here? 0,03. Please get me the number of moles of the acid and get me the number of moles of the base. What formula are we using? N equals to what? CV. Quickly. I want us to get done here. This one here is 0,0025, while this one is what? 0,003. I still cannot determine which one is more. Please. I can only determine by mole ratio. But we're saying, when we took the acid and the base, this is what we're mixing. Are you with me? Number of moles of the acid, 0,0025. Number of moles of the base, 0,003. According to my balanced reaction, what is the mole ratio? 1 mole of acid should react with how many moles of the base? 2. All right? So I'll come here and say H2SO4 NaOH. 1 mole should react with what? Please, I want you to listen to this part very well. If I have 0,0025, how many moles do I need? We cross multiply. The number of moles of base required would be what? 0,005 is needed. Does that make sense? We are saying for complete neutralization, 1 mole of the acid will always react with what? 2 moles of the base. Are you with me? Complete, according to the balance. But how many moles of the acid do I have? 0,0025. If it's complete, how many moles of the base should I be having? 0,00. But how many moles of base do I have? I need 0,005, but I have 0,003. Is it enough? So I have 0,003 moles of what? Sodium hydroxide. But I need 0,005 moles. What does that tell you? NaOH is not enough. Which makes it what? The limiting reagent. Can you tell me which one is excess? The acid is excess. It means my final solution is acidic. I don't know if that makes sense. My final solution is acidic. Why? The base is used up. It's limiting. Let me know. Thumbs up, thumbs down, those of you at home. Let's see if we're on the same page. It makes sense? Makes sense so far? All right. Now check. Guys, every calculation you do in chemistry must begin with limiting reagents. Please, I'll write that again. Calculations are done based on limiting reagents. Calculations are done based on limiting reagents. Do you buy things because you like them or because you have the money?
Both.
No, you buy based on what you have. Yes, ma'am. It's fine. You do the exact same thing if it's 2 to 3. You use any to see. I didn't know which one is excess, which one is limiting. You use anyone to identify. So what we did was we used this one too. Somebody else could have started with the base. It doesn't matter. You are only because we don't know. Can we use the base just to confirm? All right, check this. Let's check something. If I were to use the base, H2SO4 and NaOH, ratio 1 to what? 2. What's the number of moles of the base? Sorry, what do I have? 0, what? 003. Are you with me? What do I need? I need exactly half of it. So, number of moles of H2SO4 that is needed, would be what? 0,0015 by dividing by 2. But what do I have? I have 0,00 what? So I have more. So I have more than I needed. So what happens? The acid is what? And I actually need this now. Please, I want to move to the next step. Once I find out, so if I went through the first one, right? I went through the first part. I now know that my base is limited. I still need to do this. Why? I need the number of moles that is what? Excess. I need 0,0015, but I have 0,0025. What is the number of moles in excess? Are you following so far? What I need in all of this is 0,0015. But what was I given? Okay, so can I calculate number of moles of sulfuric acid in excess? What would it be? 0,0025 minus 0,0015. What's the answer? This is the number of moles that is in the final solution. It's the one that is left unattended to. 0,001 over, what is the volume? 0.55. Do you remember it is 55, right? Divided by 1,000. Please, can you give me an answer? Quickly, give me an answer. Then we try to see if we understood what I just did. Give me an answer. 15. All right? Okay, no, don't worry, I'll go back. Let's understand that. You take a picture. What's the answer? All right. 0,01818 moles per what? Cubic what? Of which compound? It is sulfuric acid that is left. All the base have been what? Neutralized. Make sense? Now, pH. What is my formula for pH? Please, can I do something here? I know some of you I didn't teach you acid and base. Please take note. The formula should actually be written like this. On the formula page, that N is not there, but be aware that it should be there. It's a diprotic acid. I need to multiply that by 2. Because I'm dealing with what? A diprotic what? Acid. So negative log 2 times 0,01818. Your answer should be less than 7. Give me your answer. Very close to 1. What's wrong? The 2. What's your answer? 1,43944. I'm done with all my marks. You need to go back and, don't worry, this is available. You need to go back and recap on this. But if you want to take a picture and take a flow, this is it. Did we need this? Okay, please take a picture or something. And please ask, let's see if we are okay. I need us to quickly go towards Casey now. Casey, very fast. But I like this question because it combines 2 things for me. It combines the one that is neutralized and the one that is not neutralized. Very interesting. Guys, please take pictures. Please take pictures so that we can move forward. So whenever we have this issue of final solution, check which one is excess. That is what determines the pH of the solution. So we add acid and base. What naturally happens? Neutralization. We check for limiting. The limiting is finished. Whatever is excess determines the nature of the final solution. And what do we do with the volume? We add. So we get the number of moles of the final solution. We get the concentration. Children, I thought you were taking... Okay. All right. Then we have this one. All calculations must be done based on what? Limiting reagents. So we're given 0,003. The 0,003 of the base, let me try to highlight a few things. This is what we have for the base, right? It used up 0,0015 out of 0,0025. That's what we explained so far. This could only neutralize this because it must be in the ratio of 1 to 2. So if I have 0,003, I have used up 0,0015. But what do I have? 0,0025. Do I have excess? Yes. What's the excess? This is the one that did not react. So concentration is number of moles. Remember, to make it make sense to you, just say number of moles of what? Excess over total volume. 0,001 is excess. Volume is that. But please remember, NH3O plus, the number of moles of hydronium. That one confused you a little bit. But are you okay? pH has no unit. Yep. Yes, Tina? pH has no units. It's just a measure of the degree of acidity. pH has no units. Huh? What? What? No. I'm very sure.
I want to ask how this works in simplified.
All right, guys, are we okay so far? Please be mind if it's a monoprotic, then you don't multiply, but you just multiply. The reason why you guys don't know is we don't show the 1 times. All right. If it's a diprotic, it's 2 times. If it's triprotic, 3 times. Okay, 1 second. Huh? Polyprotic, it's either di or tri. It's a combination. All right, we're doing well so far, guys. I love what we're doing. 22 marks, that's quite a lot. All right, let's try this one quickly.
Just like me.
Guys, let's move quickly then. I'm glad we did, at least we did organic reactions yesterday. We talked about it. Chemical equilibrium now. We've already done rates. Oh, I think we're good with time. If we can get this done quickly, then we go and talk about what? Boiling points, melting points, and all of those. All right, 2, 2, 3, 1, 6 minutes. Yes? Who's calling me? When you're doing? I'll do it while I'm at. This is Casey. I'll deal with it. Yes, talk to me. You were saying? 10 years later?
I was asking, sir, if when is the forward reaction when Casey is below?
When Casey is greater than 1. Forward. Okay, come guys, come. I need us to get this one. Let's give ourselves how many minutes? 5 minutes or 6? Please give it your best shot. Let's give ourselves 6 minutes. 2 grams of calcium carbonate is filled in an evacuated 1 dm cube metal flask, and a pressure gauge is connected to the flask in order to determine the equilibrium constant of the decomposition. The flask is heated to 800, at which equilibrium is reached. My first question, looking at that equation, is it a homogeneous or heterogeneous equilibrium? Why are you all looking surprised? Yes. From that equation, is it a homogeneous or heterogeneous equilibrium? You've heard the word homo before, right? What are homo? What do you mean no? Homo is the same. When they say homo, it's the same. Hetero means what? Different. Look at those faces, the faces of matter that we have there. What do you have? Solid, and gas. Is it the same? No. So it's hetero. It's as simple as that. It's heterogeneous what? Equilibrium. Why? Because they are not in the same what? Phase. Guys, it's as simple as that. Some of those things are things. So homogeneous means what? It is the same. Hetero means it is different. So this case, what is it? Heterogeneous. Come, let's move. The graph obtained for pressure versus volume is given as that. Define the term reaction rate. I think they're asking the same thing is it in the same paper? Oh, it was a different paper that I brought in. All right, that one is done. How does the rate of the reverse reaction change from T0 to T1? Well, let's study this quickly. What do you notice? Please listen carefully. Now we're applying it. If we increase, how does pressure affect rate of reaction? Quickly. Write this down. Increase in pressure favors the side with a fewer number of moles. Quickly. Increase in pressure favors the side with the fewer number of moles of gases. Increase in pressure favors the side with the fewer number of moles of gases. If we increase pressure, we will favor the side that has the fewer number of moles of gases. Please take note, you must put the word of gases there. Are you with me? Please let me know if we are on the same page. The number of moles of gases. Now, if I check in this, what's the number of moles of gas on the left-hand side? 0. There's no gas, it's a solid. Number of moles of gas on the right-hand side? 1. If we increase pressure, which side are we going to favor? The reverse. That's the side with the what? Fewer number of what? Moles. Are you with me? Okay. So, increase in pressure. If we increase pressure, according to this, what are we favoring? We favor the reverse. According to this one, according to this reaction. Does that make sense? You guys are busy there. If we increase pressure, we favor the reverse. The examiner says, how does the rate of reverse reaction change from T0 to T1? If you look at the graph, what's happening between T0 and T1? Pressure is increasing. So what's happening? We're favoring the reverse. How does the rate change? It's going to what? Increase. Make sense? We are favoring the reverse what? Tundani, you look lost. Where are you lost? T0 to T1. What's happening to pressure? So if we increase pressure, which one is favored? The reverse. Why is the reverse favored? Fewer number of moles of gases. With that. Number 2, what is the reason for the horizontal lines between T2 and T3? Chemical equilibrium. Huh? Just say chemical equilibrium. Don't even. What type of equilibrium? You can either say dynamic equilibrium or chemical what? Equilibrium. Please say chemical. Yeah, if I'm your teacher, I'll give you a 0. Yibo. Askis. All right. Can you please quickly answer 6.4 for me? Draw a sketch graph to show how the mass of calcium carbonate changes for the period between what? T0 to T3. What are we doing? If we are increasing pressure, can you see the pressure keeps increasing, right? What happens? We are favoring the reverse what? Which means we are forming more of that. If we are forming more, if we favor something, what happens? We form more of it, right? So what's going to happen? Please watch. This examiner is very clever.
Oh, I see, my word.
2 grams of calcium carbonate is sealed. They said the mass. What is the initial mass? 2 grams. Make sense? So what happens is, first, calcium carbonate is allowed to decompose. What's happening to the mass? It was decreasing. Like that. That's not a graph. This is normal decomposition. But now, what did we do? We increase what? Pressure. Just follow the whole system. I think my minutes are going to run out. Guys, let me create the last link, and then for the lesson, I explain this afresh. Let me create the last link for you for the day. We are almost at the tail end. You may quickly join, please. After this, we only have question 2 and 1, question 3 and 2. SGP. SGP, PXVG, PXVG, and then WD. Guys, can you hear me? Those of you at home? Uh-huh. Can you guys hear me? Those of you at home? Awesome, and you can see the screen. All right, guys, please, let's answer this question afresh again. I want you to understand what is going on here. Okay. I want you to understand what's going on here. Please, let's go back. We said increase in pressure will do what? We have calcium carbonate, right? This is allowed, the examiner says it's allowed to what? To decompose. Which means when it starts decomposing, what's going on? The mass does what? Decreases. This is what my graph should look like. We're starting from 2. It decreases until we get to a place of what? Chemical what? Equilibrium. Is that fine with you? We okay? T0, which one? Where's my chemical equilibrium? T2 and T3. All right, so we've got a T1 here. This is what's happening normally. Are we okay? Now, if we increase pressure, I want us to go step by step. If we increase pressure, what did we say? It favors which side? It favors the side with fewer number of moles of what? Of gases. What does that tell us? Talk to me. What does that tell us? The reverse is favored. Do we agree? Talk to me. And if the reverse is favored, what happens? More reactants are formed. Do we agree with that? Please talk to me. Do we agree with this statement so far? If we increase what? Pressure, we favor the reverse. It means more of calcium carbonate will be formed. Everybody okay? Now, let's go back to the question and read. I think sometimes we lose the content of the question. 2 grams of calcium carbonate is sealed in an evacuated 1 dm cube. All right? Is sealed. And pressure gauge is connected. It's sealed. So what happens? It starts decomposing immediately. Starts decreasing in mass. In order to determine the equilibrium composition of that, the flask is what? Heated to 800 degrees Celsius, at which equilibrium was reached. The graph obtained for pressure versus time for the decomposition is this. What's happening? Pressure is increasing on the y. Are you with me? As time is increasing on the what? X. Do we agree? If we increase pressure, what happens? The reverse is favored. Are you with me? If the reverse is favored, what happens? More calcium carbonate will be formed. Are we all okay with that? The examiner says, draw a sketch to show how the mass of calcium carbonate changes for the period between T0 and what? T3. What's going on between T0 and T3? We are increasing what? Pressure. As we increase pressure, what happens to the mass of calcium carbonate? It increases. We're done.
The pressure increases.
All right, so what will my graph then look like? So we are saying it gets to a particular point, right, of equilibrium, and then the graph, so let's say at this point we have equilibrium, the graph starts what? It's not going to get to 0. They want it to draw from 0. It will not get to 0. It's an equilibrium. So T0, T1, T2, T3. It's not 0 because that's what we put inside. So we allowed it to reach equilibrium, then we started increasing pressure. I hope the increase makes sense, guys. The mass is increasing. As we increase what? Pressure. So then why do you look lost? Reverse is always on your left. It's going back. That's the arrow. Reverse means go back. That is reverse. And this, your reaction will always go forward from left to right. And how do you define, please go and learn. That one will be there. They'll ask you on Monday. Define reversible reaction. I just showed you your paper. Either as and here. Reversible reaction. I'll go and find out. Go and find out. Go and find out. I have given you, I can't give you the question and still give you the memo. That's illegal now. You have your definition pages, it's right there. Okay, I'm not going to say anything, but I just give you the definition, and I just gave you 2 marks. Already you are sitting with 2 over 150 before Monday. Huh? Sorry, what I say? Can I please continue with the next question? Yeah. In my own house. I know Tepi will not close. She's not a person like that. Tepi is? I don't believe that. All right, guys, let's check this quickly. Let's check this quickly. Everybody. There's no KC. Oh, there's a KC calculator. No, there's no KC here. Maybe they broke it down. We would see. Yeah, they broke everything down because I should be seeing some 8 marks. There. All right, but anyway, let's walk through. We only have 30 minutes left, guys. During a power failure, the temperature of the oven drops to 500. Temperature change. There's a 4 marks question that learners don't know how to answer. And can I quickly deal with that before I deal with this? So that I don't forget. Learners don't know how to answer and deal with that question. Effect of KC, effect of temperature, quickly. Very fast on this. Effect of temperature on what? KC. Now, temperature is the only factor, okay guys, we'll write very fast. Only factor that changes KC value. Now, here is the question, and it's 4 marks. And I promise you, it's the last one on Monday. I won't say more than that, but it's the last one on Monday. The last question on KC is what I want to answer. All right. I'm just going to give you a prototype of the question. Is that okay? Yeah. At 450 degrees Celsius, if you find 450 there, good luck. All right? At 450 degrees Celsius, KC is 0.07. Temperature increases. Please, I want you to get this one. To 600 degrees Celsius. KC is now 0.1. Is the forward exo or endo? Explain. 4 marks. Four marks. 0. You can't get 0. You can't get 0. You can't get 0. After 2 minutes, I want to give you 4 free marks. In the next 2 minutes, rather, you'll be having 4 marks. If only you listen and follow. You don't need to cram it. Are you ready? Good. They said temperature increases, right? Statement of fact. Increase in temperature. What will it do? Will it favor the endo or the exo? That one, if you don't know that one, we're in trouble. Increase in temperature Favors which reaction? You guys are too quiet for me. Favors the endothermic. Guys, when we are cooking at home, what's happening with the food? The food is absorbing the energy. That's endothermic. So if you want the food to cook faster, what do? Increase the heat. I hope that will help you remember. Is that okay? All right. Please watch this. What did we do? We increased temperature in this case, right? But I know that increase in temperature, already I have 1 mark. Out of these 4, 25%. Increase in temperature favors the endo. Oh, sweet. Sweet. Check. What happened to Kc? Kc increased, right? Okay. We know that check is, you remember this, right? You remember that? We are now saying that Kc increased. Look, it's very mathematical. I want you to put it mathematically. If this one increases, which one has increased? Is it the concentration of product or reactants? Mathematics. Product has increased. So I'll come here and say, since Kc increased, more products are formed. Are we okay there? More products are what? Formed. If more products are formed, which reaction is favored? Forward reaction is favored. Do you know how many marks I'm sitting on already? 3 marks. How many times did I use the word favored? Please watch my highlight. Watch my highlight. Which reaction is favored? Forward. Which reaction is favored? It means endo is forward. I'll repeat. Which reaction is favored? Forward. Which reaction is favored? Endo. So can we combine both? Endo is forward. Because both of them are favored, right? Favors, endo, forward, favored. Therefore, and that's my final mark. Therefore, my forward is, let's try one. I'm going to give you one quickly. Please, I want you to try as much as possible to get it. Let's focus. 2 minutes, try it. Let's see your answer. I want to see whether you understand what I just did. Temperature was decreased. And Kc value decreased. Or let's say Kc value decreased. Is the forward exo or endo? Just do the exact thing that I did. Is the forward exo or endo? 4 marks. Please be fast. Let's see if you understand what I just did. Temperature is decreased. Let's answer this quickly. Temperature decreased, right? Okay, guys, quickly. Look, I always start with that statement of fact. That increase in what? Increase in temperature. Start with this one. It doesn't matter whether temperature decreased or increased. Start with this statement. Favors which reaction? Favors what? Endothermic. Now let's go to the question. What did we do? We decreased what? Temperature. Can we reverse this now? So what happens? A decrease in temperature favors which reaction now? Exothermic. Are we okay with this? All right, so we have our mark. So can you see I'm using the first statement as my guide? Did Kc increase or decrease? All right, Kc, check. I'm thinking in my head right now, it's like that, right? All right, if Kc value decreased, which one is favored? The reverse is favored. Am I right? The reverse is what? Favored. Because my answer decreases. I'm dividing with a big number. Oh, so Kc decreased means my what? More reactants are formed. Are you with me, everybody? We agree. Are your answers still following? Lovely. If more reactants are formed, it means what? The reverse is favored. How many times did I use favored? Reverse is favored. Favors exothermic. So what are we saying? The reverse is exothermic. What are we asking for? Forward. So the forward is endothermic. 1, 2, 3, and 4. So that look helped you. Okay. All right, are we okay? Make sense? It's some good 4 marks that I want every learner. Just approach it that way. You don't write stories. Just the exact thing I wrote down. Just write it down like that. Take every step, every change, and deal with it. All right, let's go. I don't like this question. Doesn't look like we're good. It doesn't look like we're going to get Kc calculation. I don't see a Kc calculation, but let's run. If we don't get a Kc, I need to do one. All right, during a power failure, what happens? Temperature drops. No, I see 2 marks there. Okay, let's see. During power failure, what happens? Temperature drops. What effect will this have on the following? The rate of the forward reaction. If temperature decreases, what happens? They're asking for rate of reaction. A decrease in temperature would naturally decrease what? Reaction. So what happens? Decreases. That's just simple, straightforward rate. A decrease in temperature decreases the rate of reaction. What about the concentration of CO2? Now let's go back. Let's go back to our equation. We're now talking about equilibrium. What is this reaction? If I see this, it's greater than 0, so it's what? Endothermic. What do we know? Increase in temperature will favor the endo. Which one is the endo? The forward. Now what happened? We decreased what? Temperature. Which one is favored? The reverse. More of this. So we are going to have more and less. We good? So what are we looking at? Which compound? Which compound are we looking at? What's our focus? Carbon dioxide. What happens? Decrease. Are we good? What happens to the value of Kc? If you favor the reverse, Kc will do what? Decrease. Does that make sense? Can I move on? If you favor the reverse, Kc will decrease. If you favor the forward, Kc will increase. Your question? Okay, great. Give a reason for your answer in what? 6.5.3. It's the same thing that we just did so far here. Can you see that that's my 4 marks there? What would be your reason? If we favor the reverse reaction, what happens? More reactants are formed. Equilibrium would shift to the left. I don't know if that makes sense. You don't look convinced. I have just simply answered this question. If we decrease temperature, that's what we just answered now, right? Which reaction is favored? The reverse. What does that mean? More what? Reactants are formed. If more reactants are formed, Kc value will do what? Decrease. When equilibrium was established at 800, the concentration of carbon dioxide. Okay, please watch this. Really? No, I need to find a question where I need to use a table. This is child's play here. Guys, give me your Kc expression for this equation. Ca, please quickly, don't waste time. Okay, a reversible reaction. Write down your Kc expression quickly. What is your Kc expression? Solid, gas, and solid. Quickly. Write down your Kc expression. No, write down. Why didn't the calculator? Write down your Kc expression. What is Kc? We usually say concentration of reactant, product over reactant, right? Good. So what will it be this time around? I don't like this. I need to do a question where there's real Lori McCoy. This is fake.
No, it's okay.
Hello. Who's there? To me. Hi, to me. While you are writing that, let me write something for you here. Kc forward is equal to 1 over Kc reverse. Please take note of this formula, of that expression. Okay. What is your answer here? That's the answer? To me, why are you saying 1 over though? Why are you saying 1 over? Because it's product over reactant, right? Please check. How did I get to this point? I should have written it like this. CO2, CaO, and what? Ca. This is what I should have written. But don't forget that the equilibrium constant of solids and liquids is 1. If it's a solid and a liquid, please take note, only solid. I didn't say aqueous, it's only solid and liquid. The equilibrium concentration is always what? 1. So if I cancel and cancel, do you notice I only have CO2 left? All right. Can we answer? When equilibrium is established at 800, the concentration of CO2 in the flask is that. Calculate. Are they really serious? What are you calculating? They said the concentration is 1,4 times. And we already know that Kc is this. What is the concentration? 1,4 times 10 to the power negative 2. Done. I think they want to tempt you to write a unit. There's no unit. I don't know if it makes sense. Is there a unit? No. Can I look for a real question, please? This is nonsense. Huh? Sweet. That means, guys, I'll leave you to deal with organic on your own. What's wrong? But okay, I did organic reactions yesterday. Which is the main one? Okay. All right. Let's see. Let's see. We did this today, right? We did this yesterday. We're left with this one. Okay, come. Let's do. But I really wanted to do a KC.
No, sir, please do KC. No, sir, do KC, please.
Okay. Guys, the 2020 videos answers everything, right? Summary, 30 minutes on each video. Answers everything. Every single thing that you need to know. All right, let's find one KC question to deal with. I'd love us to do one KC quickly. At least something that has to do with using the calculations and the table and the graph or something. But if you have issues, let me know. Just do questions, you know. But go through my lesson on organic chemistry before you start. Huh?
So can you answer questions?
Yes.
Sir, why is the rice best instead of chicken?
Where is?
The rice best instead of chicken.
Oh, that means you've listened to Elena.
Someone's been saying it all.
Why is it rice? What?
You said what? Why is?
Rice best instead of chicken. Someone's been saying it all the time.
Rice is best eaten with chicken.
The rice is better than chicken concentration.
Let's try this quickly. We won't take long on this. We won't take long. I'm going to guide you through on this. All right, quickly. I don't want to take long on this.
High-nitrogen tetraoxide.
All right. Dinitrogen tetraoxide N2O4 decomposes. I'm going to run. So if you're talking, you're going to lose me on this. Decomposes to nitrogen dioxide in a sealed syringe, volume of 2 dm3. The mixture reaches equilibrium at that temperature. All right. And you look at, they've given us colors. N2O4 and 2NO2. Colorless and brown. When equilibrium is reached, it is observed that the color of the gas is what? Brown. That's telling us something here. Which means more products are formed. Make sense? Because it's brown. All right. Take the Chatelier principle. You're good with that. The syringe is now dipped into a beaker of what? Ice water. What are they doing? Cooling it. If they are cooling it, what happens to temperature? That's what they should have just told us that. Okay. Temperature does what? Decreases. After a while, the brown colors what? Disappear. What does it become if it disappears? Colorless. Wait, what's going on? The reverse is favored. Are you following that? Don't just read as if it's a newspaper. It's not Life of Pi. Take time and, connect. All right? Some of you are already done here and you have given up. But I'm reading and connecting together like that, interpreting to myself. Is that okay? All right? I know the reverse is what? Favored. Wait, we decreased what? Temperature. What do I know? Increase in temperature favors the endothermic. A decrease in temperature favors the exo. Since we decrease temperature, which one are we favoring? Exo. And we see that it's colorless. And we say the reverse is what? Favored. Already I'm done. The reverse is exo. If the reverse is exo, it means the forward will be what? Endo. I'm done with my 3 marks. I don't need to write anything. I don't know. Guys, we answered this while I was explaining a while ago. Does that make sense? Decreased temperature, it favors the reverse. And a decrease will favor what? Exo. It means the reverse is exo. Forward is endo. We're done. The volume of the syringe is now what? Decreased. If I decrease volume, what am I doing? Increasing pressure. What do I know? Increase in pressure will favor the side with a fewer number of moles of gases. Is this homogeneous or heterogeneous? Homogeneous. Can you see? It's gas and gas. All my I don't even need to write down. Are you seeing? What's wrong? It's gas and gas. Homogeneous. Same phase. Okay. Guys, if I increase pressure, where do we have fewer number of moles? How many moles on the left? 1. How many moles on the right? Which one is fewer? So if volume is decreased, what am I doing if I decrease volume? Increasing what? Pressure. Which side is favored? Increase in pressure will favor the side with the fewer. Which side is favored? The reverse. It means this will be what? More. What happens to the number of moles of N2? It will what? Increase. Are we good? What happens to the value of equilibrium constant? It remains the same. Why? The only thing that affects Kc is temperature. What happens to the rate of the forward and the reverse reaction? Will it increase? Will it decrease? Guys, we are increasing pressure. Go back to rates. If we increase pressure, it will increase. Just normal rates. We spoke about the 6 factors, remember. If you increase pressure, what happens to the rate of reaction? It increases. This one is not talking about chemical equilibrium. It's talking about rates. Are we okay so far? Good. Initially, now, this is the real thing. 8 marks. The real McCoy. Initially, X moles of N2O4 are placed in a syringe. How many moles? X moles of N2O4 are placed in a syringe. What's the volume? 2 dm³. When equilibrium was reached, it is found that what? 20%. Now they're starting their nonsense now. Why percentage here? 20% of N2O4 had what? Decomposed. Are you following? The equilibrium constant is 0.16. Calculate the value of X. How many marks? 8 marks. My beautiful learners, it's 8 marks that is easier than writing your name. If you listen to me right now, if you can listen, you would get this right. But if you are talking, you would miss this. And I want to explain once. You know what your table should look like, right? What do you have here? Ratio. What do you have here? Initial. Initial what? Number of moles. What do you have here? Change in number of moles. Then, what do I have? I have what? Equilibrium. Number of moles. Then equilibrium concentration, which is number of moles over volume. My volume is what? 2. That was given. Are you with me so far? We're going to fill this very fast. Please don't lose me. What do I have? I have dinitrogen tetraoxide and nitrogen dioxide. Do you remember the ratio? It was 1:2. Do you remember the story of the question? Initially, X moles of that was placed. That's all we have. Do we have NO2? No. They said decomposition at equilibrium. What do you realize? They said 20% had decomposed. What are we left with? 80%. What is 80%? 0.8x. 80% of X at what? That's what we have left, right? With reactants, does it increase or decrease? Reactants, the quantity, will it be increasing or decreasing? Huh? It will be increasing. Guys, come on. What's the reactant doing? A reactant is what? It's reacting to form, English. To form when you are forming something, is it going down or going up? So, plus and minus. Are you with me there? Look, I don't have this, and I don't have this. I'm going to write A and B. Let's do simple mathematics. Please, I want you to do the simple maths. Although this 20, I could have put my 20% here, but I want to behave as if I don't know. Can we do maths? X minus A equals to 0,8x. Can you see what I'm doing there? X minus A equals to that. What is A? Let's do basic maths. X minus 0,8x equals to A. What is A? That's the 20% that they gave us. They said 20% add the what's 20 over 100? 0,2. They gave us. I only wanted to show you how to get that value. Let me know if you're on the same page. What's wrong? What are you analyzing? X minus A is that. Straightforward maths. 0 plus B. I don't know what this is. This is where I use my ratio. We call it a rice table, right? Kai, rice is better eaten with chicken. RNC. When I eat rice, I want to eat chicken. So, what do? I cross multiply. Rice, my rice, and your chicken. Your rice and my chicken. That will give me the value of B. What is 1 times B? B. What is 2 times 0,2x? And I'm done. I'll erase it. Use a pencil there and bring it back in. Do the math. 0 plus 0,4x will give you. Next consumption is number of moles divided by volume. What is 0,8x divided by 2? What is 0,4 divided by 2? Now I'll come and write my KC expression. Products. NO2 over what? N2O4 to the power of what? 1. Are we okay there? What's my KC? We were given KC as what? 0,16. What is NO2? 0,2x all what? Squared over what? 0,4x. I don't think this should be any difficult. 0,4x squared over 0,4x. The x would cancel there. 0,16 would be what? 0,1x. Divide both sides by 0,1. 8 marks, done. Straightforward. No issues. Straightforward 8 marks. Just go with the flow. Reactants will decrease, products will increase. Huh? Guys, go check some of the questions I did. I did quite a number of questions online, right? Press that arrow there. Guys, are we okay? It's been a long day. Yeah, just keep going. You tell you it's tough. Huh? Tina, which slide? They are going back now. I'm not sure which slide you want. Where did I buy this big phone? You want to buy the big phone as well? Next one. Let me see. Tina wants a particular.
No, you're getting lost.
Tina, what do you want? The one that says K increase 1 over K. I'm not sure whether it's this one. Guys, did you have enough information to carry you for... Okay, I hope so too.
So say the Sunday you on your own. That's what you said. Friday. Thursday. Sunday.
Pleasure, sorry. You're welcome. I'm still looking to kind here.
1, 2, 3. Thank you, sir.
1, 2, 3. You're welcome. You are most welcome.
Guys, pause. Go for it. Pause.
All right. Good night, guys. Let's talk on the group if there are things that you need help with. Okay. It's been a long day.